Hello everyone. In today's video, we're diving into the basics of electricity to understand what is electric charge, what are voltage and potential difference, what is electric current. To make these concepts simple and relatable, we'll use a water analogy and animations to visualize these ideas. Let's get started.
Welcome to Technifyi.com.
We will start by gaining an understanding of electric charge. Electric charge is a fundamental property of matter, and it comes in two types: positive charge, associated with protons, negative charge, associated with electrons. When electrons move or transfer from one object to another, an imbalance in charges occurs, leading to what we call electric charge. Normally, all objects have the same number of electrons and protons, making them electrically neutral. However, if an external force causes an object to lose electrons, it becomes positively charged because it now has more protons than electrons. Conversely, the object that gains these electrons becomes negatively charged because it now has more electrons than protons. Example: have you ever rubbed a balloon on your clothes and noticed it sticks? This happens because the balloon becomes negatively charged, and the clothes are positively charged, creating attraction between them. Fun fact: the unit of electric charge is the coulomb, C. 1 coulomb equals the charge of approximately 6.25 px 10^18 electrons. Now, to understand how electric charge flows, let's use a simple water analogy. Imagine two tanks of equal size interconnected by a passage, with the passage initially closed. Tank A is full of water, while tank B is empty. When the passage is opened, water flows from tank A to tank B until the water levels equalize. Here, the water represents electric charge, and the flow of water is analogous to the flow of electric current. In the same analogy, we can understand the potential difference or voltage. The height difference between the water levels in the two tanks represents the potential difference or voltage. It's this difference that drives the water flow, just like a potential difference drives the flow of electric charges in a circuit. So, voltage, or potential difference, is the energy per unit charge required to move a charge between 2 points in an electric field. Formula of voltage is
V is equal to W over Q.
V is voltage, in volts. W is the work done, in joules. Q is the charge, in coulombs. So, we can define 1 volt as 1 volt is the potential difference required to move 1 coulomb of charge by doing 1 joule of work. What is EMF? Electromotive force. Let's now consider a battery. A battery has two terminals, a positive terminal, high potential, and a negative terminal, low potential. Inside the battery, chemical reactions create an imbalance of charges, resulting in excess electrons at the negative terminal and a shortage at the positive terminal. This imbalance creates a force that pushes charges through a conductor when connected. This force is called the electromotive force, EMF, and it is measured also in volts, V. What is electric current? Electric current is the rate of flow of electric charge through a conductor. It's similar to the rate at which water flows through the passage in our analogy. Formula: IQT, where I is current, in amperes, Q is charge, in coulombs, T is